The Woodlands Field Old Rotation is one of the longest running late arable rotation trials in the UK and possibly the world, having been originally established in 1922. It has been used to demonstrate the effect of different nitrogen, phosphorus and potassium fertiliser combinations in 6 different fertiliser replacement scenarios across 6 different crops in a rotation. The rotation is based around 3 years grass clover followed by 3 years of exploitative cropping, with each crop grown every year. At the start of the rotation is a 3-year lay phase of ryegrass and white clover. The first year of this period is harvested and removed as a hay crop, whereas years 2 and years 3 are grazed, in this case with a lawn mower simulating livestock activity and the forage returned to the plot as if it was dung or urine. A crop of spring oats follows the grassland phase and is at the highest point of the fertility due to the nitrogen fixation that took place during the previous 3 years by the leguminous clover. Originally the oats would have been valuable as feed for horses working the land, in essence the biofuel of their day. Oats are still used for livestock feed, but there are premium markets for human use, porridge oats for example, and low GI products. A potato crop follows the oats, an important crop in this part of Scotland, particularly the seed potato industry. The last crop to be grown in the rotation is a spring barley crop, which is undersown with the grass clover mix, and once the barley is harvested in the autumn, the grass clover is present over the winter and becomes a first year grass the following year, hence returning the cycle. The only common fertiliser treatment is when farmyard manure is applied to the potato crop, which occurs 1 year in 6 within the rotation. This is at 25 tonnes per hectare, often referred to as a good mucking. Apart from this, the control treatment has no additional fertiliser applied, so very little additional fertility for almost 100 years. There are 2 treatments that receive nitrogen, phosphorus and potassium, all of which are key macronutrients for crop growth. The difference is that the first of these has phosphorus applied as triple superphosphate, which is a readily available form of phosphorus to the plants, and the second treatment of these has rock phosphate applied, which is a poorly available source of phosphorus for the plant. The next treatment contains nitrogen and potassium, but no phosphorus. Following this is a treatment that has no nitrogen applied, but does have additions of phosphorus and potassium. And finally, there is a treatment that receives no potassium, but does get nitrogen and phosphorus. Not much field activity takes place over the winter period, and there is little crop growth. Around January or early February, the ground for the spring sown crops, i.e. the oats, the barley and the potatoes, will typically be ploughed up. The cold weather over this period can help improve the soil conditions further through freeze and thaw processes, and this helps the effectiveness of secondary cultivations just prior to planting of these crops. In the spring, the ground that is to be planted with oats and barley is power harrowed to make a good seed bed, and then these crops are sown using a seed drill before the ground is rolled to help germination and reduce the risk of damage by some pests. At this point, a pre-emergence herbicide might be applied to control weeds, which will usually be followed up later in the season with further weed control measures. The ridges formed for growing the potatoes can clearly be seen here, and the cereals have established and are growing well in the better fertilised treatments. Phosphorus is an important nutrient for root development, and crops in those plots at this early stage are clearly less advanced than the others. In late June, a hay cut is taken from the first year grass and clover plots. At this point in the season, differences in the amount of clover in the plots is starting to become apparent. For instance, grass clover plots receiving no fertiliser nitrogen have much more clover in them than the plots that have received this nutrient. This is particularly true after the hay cut, when nitrogen contained in the hay will have been removed off the plots, leaving less nitrogen in the soil for the plants. The clover can fix atmospheric nitrogen through root nodules that contain a bacteria called rhizobia, and both the clover and the grass can utilise this nitrogen to help them grow. This process does require energy in the form of sugars which are passed from the plant to the nitrogen-fixing bacteria. If there is sufficient nitrogen available in the soil, this process tends to be reduced. The spring barley crop is usually the first of the cereals to be ready for harvest. This is done with a combine harvester set up to minimise seed loss and maintain seed quality. Around this time the potato crop has a desiccant applied to kill the leaves and haulms or stalks and allowed to take effect over the next few weeks. This helps the skins of the potatoes to toughen up and be more resistant to damage when the time comes to lift them. The last cereal crop to harvest is a spring oat crop, again using a combine harvester set up to minimise yield and quality of the grain. Straw from the cereals will be baled and removed from the plots. The final crop to be harvested from this trial are the potatoes. A mechanical lifter is used to dig under the potatoes and shake off the soil before leaving them on the surface. From here the potatoes are gathered up, in this case by hand, before being removed for grading in order to remove injured or diseased tubers and to put into appropriate size grades.